Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 12cc, Lesson 5 on Understanding Associations in Categorical Data. Ooh, that's a mouthful. Now in the last lesson we actually looked at categorical data, so let's do a little bit of a review on what all of that is. We can better understand categorical data, right? Data that has been divvied out into categories by examining the conditional relative frequencies that we saw in the last lesson. Remember, those conditional relative frequencies are when we divide entries in these things based on limiting ourselves down. Oh, we're only looking at the people that are children, or we're only looking at the people that are adults, etc. Now, we can do this in a more formal way, like kind of across the road for the entire table, and we'll look at that in exercise number 1. Make sure to have your calculator available for this lesson. I got mine buried down here, but we're going to need it quite a bit. Let's take a look. For his math project, Julian is trying to understand if there's a difference between whether people buy snacks at the movie theater based on whether they are a child or an adult. He asks 40 subjects exiting a movie and finds the data in the table below. All right, so let's talk about the data and then we'll get into letter A, right? So, here's Julian. He goes to a movie and he wants to figure out maybe kids buy snacks more, maybe adults buy snacks more, probably the kids, but he does this survey and he finds, okay, there's 18 people that are both children and buy snacks. There are 7 children who don't buy a snack. There are 9 adults that buy a snack and 6 adults that don't buy a snack. Then if we kind of total over, there were 25 total children that were surveyed, 15 total adults that were surveyed, 27 total people who bought snacks, 13 total people who didn't buy snacks, and obviously one of the most important numbers, 40 total people that got surveyed. So let's take a look at what we're asked to do in letter A. For each row, set up the row conditional relative frequency, oh my goodness, the row conditional relative frequency by dividing each entry in the table by its row total. Show the division / fraction, express each decimal to the nearest hundredth. Okay, so let me sort of show you what we're going to do and then I'll have you do much of the table yourself. Every single entry, every entry in this table, every single one of them, all 9 of them, I'm going to divide by whatever the row total is. Now remember, the rows are the things that go horizontal. So there's a child row, there's an adult row, there's a total row, and then there are the columns, snack column, no snack column, and total column. What I want to do is I want to divide everything in this first row by 25, everything in this second row by 15, and everything in this third row by 40. And then we'll kind of talk about it. So let's just go through a few of these ourselves. So in this first one, I want to do 18 divided by its row total 25. This one's going to work out quite nice because the 25 is such a nice number. 18 divided by 25, I shouldn't even need to round, and I don't. That's going to be 0.72. But for instance, if I went down now to that adult number at 9, here I would do 9, but I wouldn't divide by 25, I would divide by 15. This one's not going to come out as nice. 9 divided by 15. Oh, actually it does come out as nice. My mistake. Now I'm going to bring this to the hundredth, even though it's nice and even at 0.6. I'm going to do 0.60. So again, in each case, what I'd like you to do is I'd like you to divide by the row total and come up with all these different decimals. Pause the video now and go ahead and do that. All right, well, for the 7, I want to divide it by 25. So I'm going to get, let me just move this up a little bit so it's not quite as hard. 7 divided by 25, that would give me 0.28 on the calculator. Now here's going to be a little bit of a weird one. 25 divided by 25 is equal to the number 1, and I'm just going to write that as 1.00. You're going to see a lot of 1s in this table, right? Coming down here, we would have 6 divided by 15. 6 divided by 15, and that gives me 0.40. Actually, I guess I'm not going to have to round very much here at all. And then I've got 15 divided by 15, which is also 1.0. All right. Finally, in the total column, I'm going to have 27 divided by 40. 27 divided by 40. And that's going to give me 0.68 when I round to the nearest hundredth. Then here I'd have 13 divided by 40. And that's going to give me 0.33. Finally, I would have 40 divided by 40, and that'll give me 1.00. Okay, great. Let me just drag this out of the way so that we're not looking at them. All right, now, these are called row conditional relative frequencies, okay? And they're called row conditional because really what we're doing, I want you to think about this, is in the first row. Just let's concentrate on that, right? What I did was I took the number of kids who bought a snack, which was 18, and I divided by the total number of children. Now, what is that really giving me? It's really giving me the percent of children, right, who bought a snack. 72% of children bought a snack. This one, though, when I took 7 children who didn't buy a snack divided by how many children there were, I got 0.28. 28% of children didn't buy a snack. Now, when I move down and I now divide by this row total, right, which is 15 for the adults, I'm finding the percentage of adults who both had a snack, 60%, and who didn't have a snack, 40%. All right? And likewise, way down here, okay, I can also figure out the total. So the total percentage of people who bought a snack and the total percentage of people who didn't buy a snack. All right? Let's see if you understood what I just went through. Letter B. What is the overall relative frequency of buying a snack? Give an interpretation that involves percent. All right, so what was the overall frequency of buying a snack? Well, that was 0.68, right? The total number of people who bought a snack, 27, divided by the total number of people, 40. So that was 0.68. And what that means is that 68% of people bought a snack. "68% of people bought a snack." Simple enough. Now let's take a look at letter C. What is the percent of children who buy a snack? All right, well, pause the video now and write down that answer. All right, well, here it is again. If I take the number of children who buy a snack and I divide by the number of children that were in the survey, then I get the proportion of children who bought a snack, which is 0.72, but I can now very quickly say that 72% of children bought a snack. Likewise, letter D, very simple. What is the percent of adults that buy a snack? That's easy enough, right? If I look down here, right, there were 15 total adults surveyed, 9 of them bought a snack, 9/15 is 0.60, so 60% of adults bought a snack. And now we finally get to the thrust of the lesson, right? Understanding associations in categorical data, right? Letter E. Is there an association between a person's age and whether they buy a snack at the movies? Explain. Okay? So what do you think? Is there an association, or is it just, it doesn't matter whether you're a kid or an adult, you're just as likely to buy a snack? Pause the video now and give me a yes/no answer. And the answer is yes, right? It is more likely if you're a kid that you will buy a snack than if you're an adult, okay? If these numbers are the same, or roughly the same, then there's no association, okay? But what we saw, at least based on this particular data set, it is more likely that you will buy a snack if you're a child than if you're an adult. That's what's awesome about dividing by those row totals, right? And basically it kind of boils down to this. When we divide by a row total, if we look at this and we look at this and they're roughly the same, then there's really no association between the categories. On the other hand, if we look at these two and they're quite different, or these two, right? Very, very similar, then we can say that there is an association. I mean, you could think about like a more extreme example. Can you imagine like surveying 100 people, both children and adults, and saying, do you wake up on Saturday morning and watch cartoons? Of course, that was maybe a little bit more relevant when I was a child and you could only watch cartoons on a Saturday morning. But the point would be that you'd probably get like 2% of all adults that say they do that and like 80% of all kids that do that, again, maybe back in the 1980s. And then you'd see this very extreme association. Here, there's definitely an association. I mean, it's not as great of an association because there's only a 12% difference between the 60% and the 72%, but there is still something definitively there. So let's do another one of these. All right. When we divide each entry in a frequency table by its row or column total, and we'll talk just a little bit about the column totals in a bit, we are finding conditional relative frequencies. And we can compare these to see if there's an association between the categories. So let's take a look at another example where somebody is trying to find out an association. Exercise number 2. Harmony is trying to see if there's an association between the middle school grade a student is in and whether they prefer vanilla or chocolate ice cream. She asks a total of 50 6th grade and 7th grade students their preference. Her results are shown below. Letter A. Like in exercise 1, create a table containing the row conditional relative frequencies. Show your division and express each decimal to 2 decimal place accuracy. All right, so just like before, what we want to do is we want to divide each entry by its row total. So in the first row, you want to do the 9 and the 13 divided by 22, then the 12 and the 16 divided by 28, the 21 and the 29 divided by 50. Take a moment, use your calculator, and round every, decimal to the nearest hundredth if it needs to be. All right, let's do it. Bring our calculator back up. Maybe bring this over here, scroll up a little bit to give us a little more room. That'll be enough. All right, here we go. So we want to do vanilla divided by the total. All right, so clear that out, 9 divided by 22, and that gives us, we'll do 0.41. Then we're going to do chocolate divided by 22, 13 divided by 22, and that's going to give us 0.59. This will always be 1.0 way over here. 22 divided by 22, and therefore is not all that interesting. Doesn't really tell us anything. Then we go down to 7th grade. I'm going to do 12 divided by 28. And I'm going to get 0.43. Then I'm going to do 16 divided by 28. Clear this out so we can see it a little bit better. And I'll get 0.57. And again, 28 divided by 28 is 1.00. And the final one, 21 divided by 50, that would come out nice. That would be 0.42. 29 divided by 50 also comes out nice, 0.58. And 50 divided by 50, 1.00. Okay. Now, we want to make sure that you can interpret this table, right, where I divided everything by the row totals. So, take a look at letter B. What percentage of 6th grade students preferred vanilla ice cream? Simple enough. Also, letter C, let's have you answer them both at the same time. What percentage of 7th grade students preferred vanilla ice cream? All right, so pause the video now. This should be very easy now that we've got the table filled out. All right, well again, this 0.41 or 41% corresponds to the percentage of sixth graders who preferred vanilla. And hopefully that just makes sense based on how you calculate percents, right? I took the total number of sixth graders who like vanilla, which was 9, and I divided it by how many sixth graders there were, right? That's how you always come up with a percent. Part divided by total, right? That gives me 0.41, 41% of sixth graders liked vanilla. On the other hand, when I took the 12 seventh graders that liked vanilla and divide by how many total seventh graders were in the survey, 28, I got 0.43 or 43%. So now, letter D, what do your answers to B and C tell you about the association between ice cream and preference at grade level? What do your answers to B and C tell you about the association between ice cream preference and grade level? Pause the video now and write down what you think. Well, what this tells me is that there's no association, or there's very little association, one of those two. You don't want to say there's a strong association, but I would say there is little or no association because the two percentages are very close, right? And that kind of makes sense, right? Why would it just magically be that when you go from 6th grade to 7th grade, you suddenly start liking chocolate ice cream more, or you suddenly start liking vanilla ice cream more? It might be more interesting, of course, to look at the difference between, or to see if there's an association between liking vanilla and chocolate, depending on whether or not you're very young, let's say less than 10 years old, compared to whether or not you're an adult, let's say maybe even like an older adult, like 50 and older. So you may see a shift, dramatic shift over time. So it could be that older people far prefer vanilla ice cream and younger people far prefer chocolate ice cream. You might see an association there, but it kind of makes sense that between 6th and 7th grade, we wouldn't see much of an association. Now you might say, well, but those percentages are different, 41% and 43%, but keep in mind, right, just like other work we've done in statistics, here we have only a sample. We took just a sample of 6th graders and a sample of 7th graders, and we see almost no effect of their grade level on whether or not they prefer vanilla or chocolate ice cream. Now, in both the first exercise and in this exercise, we specifically looked at dividing by row totals, and most of the time that's what you do. But there is kind of a question, what would have happened had we divided by the column totals? So let's take a look at letter E. What would dividing by the column totals for this situation tell you? All right, and in this case, I'm not talking about like any kind of associations or anything like that, but literally, when we look back at this, if we now took this column and we divided each of its entries by 21, and then this column, and we divided each of its entries by 29, what would all of those frequencies, those relative frequencies, now tell me? Pause the video and think about this. You don't need to do the division. I'm just saying, what kind of information would it give us? All right, well, if we take these numbers and we divide by the total number of people that liked vanilla, what we would be finding is we'd be finding the percentage of people who liked vanilla who happened to be in 6th grade and the percentage of people who happened to like vanilla who were in 7th grade. Likewise, if we divided these two numbers by 29, we would be finding the percentage of people who liked chocolate who were 6th graders and the percentage of people who liked chocolate that were 7th graders. So specifically, it would tell us the percentage of people who liked a particular flavor that were then in 6th grade versus 7th grade. And that's a little different, right? Right? And it's important to kind of understand this. When we're dividing by the total number of 6th graders and the total number of 7th graders, then we're finding the percent of 6th graders that like vanilla and the percent of 6th graders that like chocolate, the percentage of 7th graders that like vanilla, the percentage of 7th graders that like chocolate. On the other hand, if we were to divide by the total number that liked vanilla and the total number that liked chocolate, we would literally be saying, well, look, if I just look at the people who like vanilla, what percent of them are 6th graders? And if I look at the particular people who like chocolate, which percentage of them are 7th graders, right? That would tell us that. And we could even think about associations that exist within those trends, all right? But in this case, we would still not find any kind of an association. Okay, let's wrap this up. Somehow. There we are. I knew I could get to the final screen somehow. So in this lesson, we really concentrated on what would happen if we divide all the entries in a given table mostly by row totals. And what we're doing in those cases is we're finding proportions or percentages of subgroups that fall into the various categories. By examining those, we can see if there's actually an association that exists. And if a great enough percentage, right, is different between two categories, then we can say that some type of an association exists. On the other hand, like we saw in that second exercise, when 41% of 6th graders like vanilla and 43% of 7th graders like vanilla, well, it's almost roughly the same percentage. So there wouldn't be any kind of prediction. And again, think about why this might be used. It might be used like if you're holding some kind of an ice cream social or ice cream fundraiser, and it was just for the 7th grade class. You might want to know, well, should I buy more vanilla or more chocolate because they're 7th graders rather than 6th graders? You want to know those kind of associations. All right. Well, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.